Hi. So in this session, we are going to talk about linked list. So whenever we are trying to understand a new data structure, we should try to understand that what is that particular data structure and how that data structure is different from the other data structures that we have. Because as we have seen that at the end of the day, all the data structures are trying to store data. So we will see that which particular operation is done by this particular linked list. So today we will see linked list, we will see what is linked list, and we will see what is the benefit of linked list over arrays. Since we have already seen arrays, we will try and compare both the data structures, and then we will go on to understand the concept of nodes and traversals and several operations on linked list, the basic operations that we do. So let's start now. So the very first question comes up is that what is a linked list? So here we have to store, let's say, 5 numbers 4, 5, 6, 7 and 8, 5 integers. So one option, obviously we have to store these integers in an array. So what happens with array is that in array all the data is stored in continuous memory location. So if this particular data is at address 1000, this will be at address 1004, this will be at address 1008, 1012 and 1016. So this is continuous. Now what happens in linked list? Linked list again will store this data. Let's say it stores 4, 5, 6, 7, 8. But the major difference between the two is that in case of linked list, the data is stored in non-continuous memory location. So now what do we mean by non-continuous? So here the integer is 4 byte. We know that if this is occupying 1000 address and it is having 4 bytes, so obviously from 1000 to 1003 will be occupied by this particular data. And when will the next data come? At address 1004. And this next data also belongs to the data of the same array, right? So all the elements of the array is continuous. But in linked list, it may happen that 4 is at address 1000, this is at address 3000, this is at address, let's say, 3008, this is at address 5000, this is at address 10. So it's not continuous, right? So the next address to 1000 is 1004, where the element could have been stored. So, but it's not stored in the next memory location. It is getting stored somewhere else in the memory. So the major difference is that it is having continuous memory location, it is not continuous. Now the question is, in case of arrays, if we have to traverse through the elements, or if we have to just go through all the elements that we have, we start from the first element. And since we have the index and we also know that the elements will be in continuous fashion, it's really easy. Let's say you go to address 1000, you go to address 1004, 1008, 1002 and 1016 and you can access all the elements. So we know that if one starting address is 1000, next address is going to be 1004. But here, let's say I know that the first address is 1000. The first element is stored at address 1000, but still we don't know that what is the next address. So for knowing that which is the next node, this previous node stores the address of the next node. So what will happen? So generally linked list looks something like this. So we have two parts for a particular node. So each of these elements are called node, let's say. So this is a node, this is a node. So each node has two parts. First part is having the data. So in this case data is 4, and the second part is having address of the next node. So in this case the next node is 5. So here we have 5, and now this particular node will have the information that where do I have the next node in memory. So now this particular node will be pointing to next node in the memory, which is having address 6. Now this 6 will be pointing to next node, which is at address 7. Sorry, which is having value 7, and then we have the last node having value 8. Now the question is that now last node is not pointing to anything else. So last node will have null in the address field. Now the question is, I'm talking address here. So like this particular node is storing address of this particular node, this is storing address of this particular node. So when we are talking in C++, we have option of storing address using pointers. But in case of Java, we deal with objects and we talk in terms of objects. So now let's see that if we have to implement linked list using Java, how do we do that? So now, before we go on to discuss about that, how do we implement linked list in Java, there is one major thing that we need to see. So we have seen that if we have to store number 4, 5, 6, 7, we can store that using arrays as well as linked lists. Both of them can easily store the elements. Now the question is, what are the benefits or disadvantages of using arrays over linked list or vice versa? So let's see few of the important points. So the very first important point is that size of the array is fixed. So whenever we are creating the array, we give the size of the array. So let's say I give the size of the array is going to be 10. So we cannot go beyond 10, right? So we cannot go beyond 10 and start storing elements. So let's say in this case it's 5. So let's say I have taken an array of size 5. Now let's say we have to store one more number. We have to store one more number here. We can't do that because I have already created my array of size 5 and we cannot expand that. Even though we have options of expanding in case of dynamic arrays, what we do is we cannot add single nodes. We cannot add single elements. What we do is we create a new array of size double or 2 times, and then we copy all the elements in that another array. So you can see that the method of increasing the size is very complicated, and in general, once we have created an array of particular size, we cannot change the size of the array. But that is not the case in case of linked list. So in linked list, we can easily add one node. So here we already have 5 elements. Let's say I want to add just one more element. So I can easily add one more element to the linked list. Or for that matter, let's say after some time I realize maybe I need to add one more node. So we can add one more node. So let's say we can store obviously more data. So we can store the elements, we can add nodes in a very dynamic fashion in case of linked list, but in case of arrays, that is not possible. Now let's talk about what happens when we have to insert or delete an element. So if we have to insert an element, let's say in case of arrays, so let's say we have to insert it, let's say we have an array of size 2000. So let's say we have to insert an element at let's say 3rd index. Now for storing the element at 3rd index, what we have to do is, let's say this is my array. So this is 0, 1, 2, 3. Let's say I already have few stuffs like 2, 5, 6, 7, 8. So for storing an element here, we have to first make room for this particular element. So let's say we have to store 9. So we have to make room for 9 here. And for that, what we have to do is we have to shift all the elements to the right. So we will be shifting all the elements to the right, and then we are going to store 9 here. So you can see that there is a lots of tasks that's happening. So the time complexity is all O of n in case of inserting an element, because we have to make a room for it. We shift all the elements to the left. So worst case, it might happen that I have to make it here, right? And then we go on to insert the element. This is a problem. But what happens in case of linked list is, let's say we have these 4, 5, 6, 7, 8, and we have to insert an element in between 5 and 6. So what we can do is, simply we can change the link. We will see how to insert elements in linked list, but we can just change the links. We just have to change the links. 5 will start pointing to that new node, and the new node will start pointing to 6. So now this is how my linked list will look. So we will see again, we will see how to do this. But in case of linked list, we just have to change the links, and the operation can be done in O of 1 time for insertion. Now let's talk about deletion. In case of deleting also, let's say we have 2000 elements. So for, let's say I have 2, 3, 4, 5 till 2000 elements. Now let's say I have to delete 3. So if I have to delete 3, then if I delete 3 from here, it becomes empty, let's say. Now we can't leave this particular thing as empty. So we will have to shift all the elements to the left. So again the time complexity becomes O of n. In this case again, let's say I have to delete 5. So if we have to delete 5, we just have to change the links again. Now 4 will start pointing to 6 and we just have to remove 5, this particular node, whatever space this particular node is occupying from the memory. So again this is having time complexity of O of 1. Great. Now let's proceed towards the next point, which is accessing an element. Now let's talk about accessing an element. So now let's say I have to access the element 7 here, okay. So in case of arrays, it's really simple. You just need to know the index and you can directly, let's say if the array name is AR, you can simply do AR 2 or for that matter AR 3, 4 to access this particular element. Or even if you just have the address, so if I know that it's the base address is 1000, I can easily access this particular element because I know that if this is 1000, it is going to have the addresses 1012. So this will have 1004, 1008 and 1012. So as you can see that I can directly access any element in case of array, the time complexity is going to be of 1. But in case of linked list, what happens in case of linked list is we always have the address of first element or the first node. So we always have reference to the first node. I know always that where the first node is lying in the memory. I don't have more information apart from that in case of linked list. So for let's say accessing 7 here, what I have to do is I have to start from first node, I have to go to second node, third node, fourth node, then I get to access that particular element. So in case of linked list, the time complexity is going to be O of n for accessing any element. Whenever you are writing a code, just see that what are the operations that's going to be performed. So if you are writing a code where there is going to be lots of accessing an element randomly, especially randomly, then it makes more sense to use arrays. But if you are writing some code where there might be lots of change in sizes or might be lots of addition of elements, in that case you can use linked list. Or you have to lots of, let's say, do the insertion and deletion, then you can use linked list. So always just see that what are the operations that you have to perform in your code and you can use the data structures accordingly. Now another thing about is ease of use. There is no doubt that arrays are much easier to use than that of linked list. So now let's say if you just have to perform sorting. Just think that if you have to write code in array, then it will be much easier than writing code in linked list for sorting. So depending upon again what are the operations that you are performing, you can use arrays or linked list. Now let's see how do we implement linked list in Java. So now we have to talk about linked list in Java. So we saw in previous slide that we have several nodes. Each node has two fields. One field contains the data, another field contains the address of the next node, that where the next node is lying in the memory. This is how it goes. So here we have 4 and then we have address of next, let's say it's 5, and then we have address of next, let's say it's having data as 6, 7, 8, and last node will not have any address, it won't have any address. Now this is the data, this is having the address, but we know that in case of Java we don't have concept of address. So how will I get to know that where is the next node lying? So in case of Java you have to think each node as an object. Each node is an object in memory. And for knowing that where the next object is lying, you have to have reference to that particular object. So what we do in Java is that, let's say we have something like, let's say node. So now this node is an object variable. It's a variable, right? And we create, let's say we create a new node. So now this node is an object variable, and wherever this node is created in the memory, so let's say this is the memory, wherever this node is created in the memory, this object variable node will point to that particular object. So this node is having reference to this particular object, this object that is getting created. Similarly here we have one field data, which is containing the data. Obviously, we have another field which will contain reference to that particular object. You can think of that as a object variable. So if this is node, let's say it's a node object, let's call that this is node object, and this is also node object, then this particular field has to be an object variable of node, such that it can point to, or it can contain reference to another node that we have in memory. So one field is going to be data, and for address we are going to have node. So this is the object variable which is containing the reference to the next node. So this is how we implement node in linked list. Node in Java, we don't have address, we contain reference to the objects. Now we will see how do we implement various operations and what are the various operations in case of linked lists. So we are going to see various linked list operations that we have. The number one is inserting an element into the list. Now the insertion can be at any place. It could be before the list, it could be at the end of the list, or it could be somewhere in the middle. We will talk about it. Another is delete. Remove and return this specified element from the list. So let's say we delete 6. Let's say someone tells you that you delete 6 from this particular linked list. This complete is a linked list. From this particular linked list, you delete 6 and you print 6. So this is one operation that we are going to do. Then we have delete list. So remove all the elements from the list and remove complete list from the memory. Then we have count, which counts the number of elements in the list. So here we have 1, 2, 3, 4, 5 elements in the list. So these are few operations, and then we have nth node from the end of a linked list. So these are the primary operations that you are going to see, and then we are also going to see these particular operations. So now let's see that how do these operations happen in linked list. So the very first is inserting an element in the linked list. So when you have to insert an element in the linked list, before going on to write the code and before going on to see how do we do that, let's just create the classes that we will need. Then, because obviously Java is about classes and objects. So as we discussed that this individual boxes are the nodes, they are the node objects, and this complete thing is the linked list. This node will have two members. One is data. So this data takes care of the data that is getting stored. It could be an integer, it could be a character, it could be a string, depending upon the data that we are storing. And another is a variable of type node. So this is the same variable, object variable, which is going to store the reference of next node that is there. And we also have a constructor node. We will see how we can use this constructor to create obviously a new objects. So this is node, which is taking care of these small boxes, as you can see. And then we have class linked list, which is responsible for this particular linked list that is here. So in this linked list, we'll have a head variable. So this head is something that always points to the first node of the linked list. So this head always points to the first node of the linked list. So initially we'll have head is equal to null. So let's say the linked list is not having any element and it's completely empty, which means that head is going to be null. It is not pointing to any object in the memory. So head equal to null tells us that there is no such linked list that exists as of now. Is that while creating the class linked list, we are implementing all the methods. Now what happens is that if let's say there is some other class who wants to use linked list, who wants to use this particular linked list, the class will just call these operations. So the class will just call these methods. So if someone has to if someone has to, let's say, create a linked list, the person will just call this linked list class. It will just use the methods of linked list to create it, or for that matter, it has, let's say, the person has to insert an element in the linked list. So it will just call insert operation. It will not bother that how this insert operation is happening. So when we are creating a class linked list, we are also telling that what are the operations that this particular linked list class can perform. So like we also have collections in Java where we have a linked list which is already implemented, and whenever we are, if you have already used it, whenever we have to use it, we just create object of the linked list class and we go on to call the methods on that particular object. So what we are trying to do here is we are trying to implement this class from the scratch. So in case of insertion, there could be three types of insertion that can happen. So I'm taking different methods to make you understand this better. So number one is that, let's say someone wants to insert an element somewhere in the middle. In the middle means it could be between 4 and 5, between 5 and 6, 6 and 7, 7 and 8, which means that between any two nodes. Or you want to insert at beginning. So let's say I want to insert a node here, or I want to insert at the end. So I've taken three methods for them, and let's see one by one that when you have to insert an element in the linked list, how do we do it?